In previous lecture, we have proved one important theorem. If your given sequence xn is a monotonically increasing sequence and which is bounded above, then it is converges to its least upper bound, or it is a convergent sequence. So take an example on this theorem. Show that sequence xn is equal to 1 upon n plus 1 plus 1 upon n plus 2 plus dot 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 1 upon n plus n is convergent sequence. So we want to show that this sequence is convergent sequence, and to show this sequence is convergent, we are going to apply the previous theorem. Okay, if we want to apply the previous theorem, then first we want to show that this sequence is a monotonically increasing sequence. So in step first we are going to show that the given sequence is monotonically increasing sequence. For that, find the next term xn plus 1. So what is xn plus 1? It is 1 upon n plus 2 plus 1 upon n plus 3 plus dot 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 1 upon n plus 1 n plus 1. So it is twice n plus 2. In place of here, if you put n plus 1 and again here n plus 1, then n plus 1 plus n plus 1, it is equal to twice n plus 2. Or this xn plus 1 can be written as 1 upon n plus 2 plus 1 upon n plus 3 plus dot dot dot. What is the previous term of this term? Okay, previous term of this term is 1 upon twice n plus 1 upon twice n plus 1 plus 1 upon twice n plus 2. So you could take xn plus 1 minus xn, then this 1 upon n plus 2 minus 1 upon n plus 2 will get cancelled here. 1 upon n plus 3, 1 upon n plus 3 will get cancelled here. 1 upon twice n, 1 upon twice n will get cancelled here. So what is left? 1 upon twice n plus 1 plus 1 upon twice n plus 2 minus, here is one term is left, it is 1 upon n plus 1. So if you simplify here, from this term if you take 2 outside, then xn plus 1 minus xn is equal to 1 upon twice n plus 1 plus 1 upon 2 times n plus 1 minus 1 upon n plus 1. So if you observe these two terms, if you take the LCM here, multiply here by 2, then 1 minus 2 is minus 1. So what is xn plus 1 minus xn? It is equal to 1 upon twice n plus 1 minus 1 upon twice n plus 1 means what? Twice n plus 2. And we know that twice n plus 1, that is twice n plus 1 is less than twice n plus 2, and therefore 1 upon twice n plus 1 is greater than 1 upon twice n plus 2, and therefore 1 upon twice n plus 1 minus 1 upon twice n plus 2 is greater than 0. If we take this term to this side, then this is greater than 0, implies this is greater than 0. But if this term is greater than 0, implies xn plus 1 minus xn is greater than 0. So what this implies? Xn plus 1 is greater than xn. So what this implies? Xn is less than or equal to less than xn plus 1, and what this implies? It is a monotonically increasing sequence. Next term is greater than the previous term. What is for every n? What this implies? The given sequence is a monotonically increasing sequence. Now, next step, we are going to show that this sequence is also bounded above. The sequence xn is a bounded above. If we show it is a bounded above, then by using a previous theorem, we can say that this sequence is a convergent sequence. So, what is step number 2? Bounded sequence. Step number 2. Bounded sequence. Now what is xn here? Xn is equal to 1 upon n plus 1 plus 1 upon n plus 2 plus 1 upon n plus 3 plus dot 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 1 upon n plus n. Then all of we know that n plus 1 is greater than n plus 1 is greater than n. What this implies, 1 upon n plus 1 is less than 1 upon n. Similarly, n plus 2 is greater than n, and therefore 1 upon n plus 2 is less than 1 upon n. So all these terms are less than 1 upon n plus 1 upon n plus dot 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 1 upon n. But how many of these terms? 1, 2, 3, n. So how many terms are there? N terms are there, and denominator is same. So we can add numerator. So n times 1 means what? It is equal to n by n, which is equal to what? 1. So xn is less than or equal to 1 for every n. Xn is less than or equal to 1 for every n, and therefore what this implies? This implies sequence xn is bounded above. Since it has the upper bound, each of these terms is less than or equal to 1 means what? 1 is the upper bound of this sequence, and therefore sequence xn is bounded above. And therefore from step number 1 and step number 2, what we can say that since xn is monotonically increasing sequence and it is bounded above, and therefore this implies xn is convergent sequence. Xn is a convergent sequence. This is what we want to show that. Now next, take one more example. Show that the sequence xn is equal to twice n minus 7 divided by thrice n plus 2 is monotonically increasing and bounded above. And hence show that monotonically increasing. Number 2, show that it is bounded above, and number 3, show that it is convergent, and hence find its limit also. What is given? Xn is equal to twice n minus 7 divided by thrice n plus 2. So what is the step number first? Monotonically increasing sequence. We are going to show that this sequence is a monotonically increasing sequence. So now consider again what is given here. Xn is equal to twice n minus 7 divided by thrice n plus 2 implies what is xn plus 1. Xn plus 1 is equal to, in place of n, input n plus 1, that is twice n plus 2 minus 7, so it is minus 5 divided by thrice n plus 3 plus 2, so plus 5. So if you take xn plus 1 minus xn, then twice n minus 7, twice n minus 5 divided by thrice n plus 5 minus twice n minus 7 divided by thrice n plus 2. Thrice n plus 2. Now, if we simplify this, how to simplify? Take LCM here. So xn plus 1 minus xn is equal to what? Multiply twice n minus 5 by thrice n plus 2. So if you multiply here, it is equal to twice n into thrice n, it is equal to 6n square plus 4n. Similarly, this is what? 6n square minus 6n square. Okay, sorry. Want to multiply minus 5 also. So multiply by minus 5 too. So it is equal to minus 15n minus 10. Now next multiply this thrice n plus 5 by twice n minus 7. Then it is equal to twice n thrice n. It is equal to minus 6n square. Then minus 10n. Then next minus minus plus, so 21n, and again minus minus plus 35. This whole divided by thrice n plus 5 and thrice n plus 2. So if you simplify this 6n square minus 6n square plus 6n square will get cancelled here. Then what? Minus 15n and minus 10n, it is equal to minus 25n. So minus 25n and plus 25n will get cancelled here, and 35 minus 10, it is 25. So it is 25 divided by thrice n plus 5 into thrice n plus 2. Now if you observe, all these terms are greater than or equal to 0. So 25 is greater than 0. They are all positive numbers. This is greater than or equal to 0. What this implies? Xn plus 1 minus xn is greater than 0, and therefore xn plus 1 is greater than xn for every n. That is, xn is less than xn plus 1 for every n, and therefore xn is monotonically increasing sequence. It is what? Monotonically increasing sequence. Now, if you want to show that it is a convergent sequence, we have to show that it is also bounded above. It is bounded above. So if you write few terms of this sequence, you can guess that all these terms are less than or equal to what? 1. All these terms are less than or equal to 1. If you write few terms of this sequence, you can guess that all these terms are less than or equal to 1. So I am writing here 1 minus xn. So what is 1 minus xn? It is 1 minus twice n minus 7 divided by thrice n plus 2. So it is equal to thrice n plus 2 minus twice n plus 7 divided by thrice n plus 2. If you take LCM here, if you multiply by this sign here and minus sign to this bracket, then we will get thrice n minus twice n, it is n, and 2 plus 7, it is equal to 9 divided by thrice n plus 2, and it is greater than 0. This term is positive, so 1 minus xn is greater than 0. But what this implies? 1 is greater than xn for every n. That is, xn is less than 1 for every n. Xn is less than 1. What this implies? Xn has upper bound. Means what? Xn is bounded above. Bounded above. So the given sequence is monotonically increasing and bounded above. So by using the previous theorem, what we can say that since xn is monotonically increasing and bounded above, and therefore it is convergent sequence. It is a convergent sequence. And what is its limit? Limit n tends to infinity, xn is equal to limit n tends to infinity twice n minus 7 divided by thrice n plus 2. What is the largest power of n on the numerator? 1. And so take it outside. Also on the denominator, what is the largest power of n? It is 1. So take it outside. If you take n outside from the numerator and denominator, it is equal to limit n tends to infinity n inside the bracket 2 minus 7 by n divided by n 3 plus 2 by n. So what happened here? This n will get cancelled here, and all of you know that 1 upon infinity is what? 0. So 7 upon infinity is 0, 2 upon infinity is 0. So it is 2 minus 0 divided by 3 minus 3 plus 0. So limit is what? 2 by 3 3. So this equation converges to limit is what? 2 by 3. So we are going to stop here for today.